Hi everyone. In this video we're going to learn an algebraic identity known as the Sophie Germain identity. And before we take a look at it, we're going to warm up with a factoring problem. So let's factor x to the fourth plus x squared plus 1. Go ahead and pause the video and give it a try. Okay, the key to factoring this is an idea known as completing the square. So what I'm going to do is add an x squared to this expression, arriving at this, and then subtract an x squared. And the purpose of doing this is that the first three terms now factor into a perfect square, x squared plus 1 squared. And now we have a familiar form. It's called a difference of squares, and this factors into x squared plus x plus 1 times x squared minus x plus 1. Okay, let's try another similar factoring problem. Let's factor a to the fourth plus 4b to the fourth. Go ahead and pause and give it a try. Okay, similarly, we can complete the square here. What we want to add to this expression is 4a squared b squared. That will create a perfect square, and we have to subtract 4a squared b squared. So the first three terms will factor into a squared plus 2b squared all squared. And the last term can be written as the quantity 2ab all squared. So again, we get this difference of squares, and when we factor it, we end up with a squared plus 2ab plus 2b squared times a squared minus 2ab plus 2b squared. All right, and this result actually is the Sophie Germain identity. So this identity is useful for students taking math contests because sometimes contest writers write problems where this is the major tool used to solve it. So you can memorize this identity, or better yet, you can remember the procedure of completing the square, which is what I would do. All right, and here is a basic problem that uses this identity. Let's show that 2021 to the fourth power plus 4 to the 2021 power is composite. Well, this looks very close to the left-hand side of the Sophie Germain identity. In fact, we can write it as 2021 to the fourth plus 4 times 4 to the 505 power all to the fourth power. So it has the form a to the fourth plus 4b to the fourth, where a is 2021 and b is 4 to the 505. So we're going to factor it, and the result above was a squared plus 2ab plus 2b squared times a squared minus 2ab plus 2b squared. But let's fill in the numbers for a and b and see what this looks like. This would be 2021 squared plus 2 times 2021 times 4 to the 505 plus 2b squared, which would be 2 times 4 to the 1010 power. And the second factor is similar, but with a subtraction right there. Okay, so we've taken the given number and we factored it, and so maybe that means it's composite. Well, that would be true as long as both factors are greater than 1. Well, the first factor is clearly greater than 1. All the terms are positive. So let's look at the second factor. In particular, let's look at the last two terms in that factor. Negative 2 times 2021 times 4 to the 505 plus 2 times 4 to the 1010th power. Well, we can factor. I can take out a 4 to the 505, and I'd be left with negative 2 times 2021 plus 2 times 4 to the 505. And this factor in the parentheses, I think you can agree, is clearly a positive integer. 4 to the 505 is much greater than 2021. So this is greater than 1, and when you add the 2021 squared to it, of course, it's greater than 1. So we've factored the given integer into a product of two positive integers, each greater than 1, and therefore it is composite. Okay, let's end the video by just reading the introduction from Sophie Germain's Wikipedia page so we can find out who this identity is named for. So Marie Sophie Germain, born in 1776, was a French mathematician, physicist, and philosopher. Despite initial opposition from her parents and difficulties presented by society, she gained education from books in her father's library, including ones by Leonhard Euler, and from correspondence with famous mathematicians such as Lagrange, Legendre, and Gauss. Her work on Fermat's last theorem provided a foundation for mathematicians exploring the subject for hundreds of years after. Because of prejudice against her sex, she was unable to make a career out of mathematics, but she worked independently throughout her life. Before her death, Gauss had recommended that she be awarded an honorary degree, but that never occurred. In 1831, she died from breast cancer. At the centenary of her life, a street and a girls' school were named after her, and the Academy of Sciences established the Sophie Germain Prize in her honor. Okay, thank you for watching this video.